Welcome to this explainer. I want you to take a quick look around the room you're in right now. Really look at it. The flat floor you're walking on, the chair you're sitting in, the keyboard or screen you're touching, all of it is a direct reflection of our primate biology. We are heavy, ground-dwelling apes with flat feet and opposable thumbs, and we have completely biased the way we build our world. Our technology is built entirely for us. But what if history had taken a very, very different path? What if the asteroid that wiped out the dinosaurs had spared a lineage of theropods that eventually evolved human-level or even superhuman intelligence? Now, you might think high intelligence is unique to our massive human brain size, but modern neuroscience actually shows us that bird brains pack incredibly high neuron densities that easily rival primates. I mean, a tiny raven's brain is capable of complex planning and abstract thought? Okay, let's dive into this, because if a hyper-intelligent avian species developed a technological civilization, their world would look absolutely nothing like ours. And their biology brilliantly illustrates exactly why. Think about it. We are defined by our heavy mass and our two-dimensional flat movement, relying super heavily on our opposable thumbs. An avian species is the complete opposite. They are defined by their lightweight biology, incredible three-dimensional vertical freedom, and their use of beaks and talons. Their technology wouldn't just be a slightly tweaked version of ours, it would be totally alien, built from the ground up to accommodate a completely different set of physical laws and bodily constraints. Which brings us to Section 1, the missing hand dilemma. Because obviously, to build a civilization, you first have to build tools. But how in the world do you smelt metal, build engines, or engineer complex machinery if your front limbs have been entirely converted into wings for flight? Well, the solution lies right in their anatomy, specifically zygodactyl feet. You can actually see this foot structure in modern birds, like parrots. It features two toes facing forward and two facing backward. This setup allows for surgical precision and just extreme vice-like grip. Now combine that grasping power with a thick, muscular tongue that acts almost like a third limb and a highly sensitive keratin beak. Boom. An avian engineer completely bypasses the need for human hands entirely. So their industrial revolution wouldn't start with someone swinging a heavy handheld hammer. It would kick off with peck-and-clasp engineering. Picture this. Instead of standing at a workbench, an avian builder hangs securely from a suspended harness, totally freeing up both sets of talons. They equip custom-molded wearable beak extensions, maybe made of bone or resin, to multiply their gripping power. And for running heavy machinery, like a lathe or a drill, they'd power it using reciprocating foot pedals, tapping into the immense strength of their flight-adapted leg muscles. And as their tech gets more advanced, you wouldn't see a single keyboard or push button anywhere. Birds rely completely on their beaks for survival, so there's no way they'd risk chipping them on hard plastic keys. Instead, their control panels would feature these highly polished, tactile globe controllers, basically smooth spheres they'd roll with their beak or tongue. Below that, advanced machinery would be operated by pressure-sensitive foot clutches, where a single talon shifting its tension just slightly could adjust dozens of microsensors all at once. Let's move to Section 2, 3D metropolises, and see how this builds out. Because once you master tools, you start building cities. And for a flying species, the flat ground is something you leave far, far behind. Welcome to the avian meganest. Here, you'll see a total abandonment of human architecture. I mean, flat floors are totally meaningless to a species that purchase, right? Instead of pouring concrete on the ground, their homes would be these aerodynamic pods suspended high up on sheer canyon walls. Inside, 0 chairs, 0 beds. The walls would be lined with temperature-controlled ergonomic perching rings and these plush suspended hammocks. And to get inside, they wouldn't use front doors. They'd fly straight up through funnel-shaped landing portals right at the bottom of the pod. But here's the catch. Flying constantly is exhausting, high-energy work. So how do they commute vertically in these massive canyon cities every day without burning out? They'd engineer their entire city to be a living wind tunnel. By placing industrial heat outlets or geothermal heaters down at the canyon floor, they generate permanent artificial thermal updrafts. An avian citizen doesn't need to flap frantically to go upstairs. They simply step out, spread their wings, and ride these thermal elevators up to the higher districts with literally 0 metabolic cost. It's an absolutely genius, energy-free transit system. All right, Section 3, tetrachromatic and magnetic networks. Now we really have to shift our perspective even further and look at sensory biology. Because if a sapient bird tried to interact with our human technology, they would find it physically uncomfortable, super confusing, and just blindingly dull. Here's why. We humans are trichromats, meaning we see combinations of red, green, and blue. But birds? They're tetrachromats. They possess a whole fourth cone receptor, allowing them to see ultraviolet light, plus specialized oil droplets that filter light for insane detail. So an avian smartphone or monitor wouldn't be RGB, it would be RGB UV. And because many birds can actually perceive the polarization of light, they could use polarized filters right on their screens. This means a single monitor could display two completely different data feeds simultaneously, just depending on how the bird adjusts its gaze. This changes how their entire civilization looks. To human eyes, an avian city street, a billboard, or even a printed book might just look like a totally blank white surface. But to them, those surfaces are glowing with incredibly intricate, detailed ultraviolet patterns. Their written language and city signage are literally hidden in plain sight, completely invisible to our limited primate eyes. Now, what's really interesting about this slide is this incredible sixth sense they possess, magnetoreception. Through wild quantum mechanical reactions happening in specialized cryptochrome proteins in their retinas, birds can literally see the Earth's magnetic lines of force. It acts as an organic built-in compass that's overlaid directly onto their visual field. So think about what that means for navigation. An avian society wouldn't bother launching massive heavy metal rockets into space to build a GPS satellite network. Why would they? Instead, they'd just construct magnetic beacon towers across the landscape. These elegant towers would emit gently pulsing modulated electromagnetic fields. An avian pilot caught in dense, blinding fog wouldn't even need a digital dashboard. They would physically feel and see the local magnetic fields shifting around them, blindly navigating safe aerial corridors completely by instinct and engineered magnetic pulses. Moving on to Section 4, Materials of the Wind. This deep reliance on the air completely dictates their entire material science. For humans, weight was never really a massive issue until we decided we wanted to fly. But for them, weight is the ultimate enemy right from day one. If we compare our developmental timelines, humans went from hauling heavy stone to iron and eventually to solid steel and concrete. A flying species simply cannot afford to drag heavy stone and cast iron up into the trees or cliffs. They would bypass the Stone Age entirely. Instead, they'd kick things off with a biopolymer age, utilizing ultralight plant fibers, natural adhesives, and spider silk proteins. Their early tech tree is all woven and tensile, incredibly lightweight but possessing the immense strength of modern carbon fiber. And when they finally do reach the age of metallurgy, they certainly aren't casting solid, heavy steel beams like human architects do. They would biomimic themselves. Just like bird bones are hollow and internally braced by tiny struts to save weight, avian architecture would feature 3D-printed, hollow-core, numinized metal trusses. Their machines and bridges would look gossamer, delicate, and skeletal, like a giant metallic spiderweb, yet capable of withstanding massive aerodynamic forces. And finally, Section 5, the Syrinx Symphony. Let's look at the grand finale of this explainer. Computing and language. We humans use a larynx, which is linear. We speak one note, one sound at a time. But avian biology offers something so much more powerful. They possess a syrinx. This is an absolute anatomical miracle. It's a complex, Y-shaped organ sitting right at the base of the trachea that lets birds produce two entirely different sounds simultaneously. They can literally sing a duet with themselves. Imagine an ascending, high-pitched melody on the left side, perfectly synced with a rhythmic bass line on the right. Because of this incredible organ, their spoken language has a data density that completely shatters human speech. And this means their computer interfaces aren't built on typing out binary ones and zeros on a keyboard. Avian programmers would literally write software by singing to their machines. They would use acoustic waveform matrices. Just imagine an avian coder singing the operational address of a database with one side of their syrinx while simultaneously singing the mathematical function to execute with the other side. High-density, real-time acoustic coding. It's unreal. So the crucial point is how this applies to cybersecurity. For them, a password isn't a string of typed text. An avian password requires the exact physical syrinx signature of the user. Their computers' biological microphones would listen for specific micromuscle patterns and the exact resonant frequencies of that one specific bird's vocal tract. It is an acoustic security system that is virtually impossible to spoof. You know, when we look at speculative evolution, it is just so easy to assume human technology is the only right way to build a world. But biology is really just the lens through which we manipulate physics. An avian civilization would be whispering, vertical, and perfectly in harmony with the fluid dynamics of our sky, as this quote beautifully summarizes. The path to the stars doesn't have to be paved with concrete and iron. Sometimes all you need is the right perspective and the wings to carry you there. Just imagine that woven carbon fiber solar sail quietly slipping out of Earth's orbit. And that brings us to the end of our journey today. But before we go, I want to turn it over to you. Looking at their wild biology, their hollow bones, their tetrachromatic vision, their syrinx, what other strange pieces of technology do you think an avian civilization would invent? Get creative and share your own speculative ideas with us in the YouTube comments below.
Please like and subscribe.